Welcome to an exploration of C++ compilers, the unsung heroes that transform your human-readable code into executable programs. Understanding their role is crucial for every C++ developer. What is a compiler? A compiler is a software tool that translates source code written in a high-level programming language, BIKE, into machine code or an intermediate code that a computer's processor can directly understand and execute. This translation process happens before the program runs. Source code. High-level language written by developers. Compilation. Translation process, error checking. Executable code. Machine-readable instructions ready for execution. What is an interpreter? An interpreter, in contrast to a compiler, translates and executes code line by line, without generating a separate executable for. This means the translation happens during runtime, directly processing the source code. Read line. The interpreter reads one line of source code. Translate and execute. Translates that line into machine code and executes it immediately. Next line. Move to the next line, repeating the process until finished or an error occurs. Compiler versus interpreter. Key differences. Translates entire program at once. Generates an executable file. Execution is faster once compiled. Error detection before runtime. Examples: C++, C, Java, low-by-line code. Translates and executes line by line. No separate executable file. Execution is generally slower. Errors detected during runtime. Examples: Python, JavaScript, Ruby. Advantages of each. Compiler advantages. Optimized performance. Produces highly efficient code wading to faster execution times. Ideal for performance-critical applications. Standalone executables. Create self-contained programs that can run without the source code. Simplifying distribution. Early error. Detection catches many types of errors during compilation, reducing runtime issues. Interpreter advantages. Platform independence, Orion more portable as the source code can run on any system with an interpreter. Ease of debugging. Line-by-line execution simplifies cadencing and fixing errors. Rapid prototyping. Changes can be tested immediately without recompilation, accelerating development cycles. Drawbacks of each. Compiler drawbacks. Development time. Requires a separate compilation step, which can be time-consuming for large projects. Platform dependence. Compiled executables are platform-specific. Example, Windows.exe won't run on macOS directly. Less flexibility. Difficult to make small changes without recompiling the entire program. Interpreter drawbacks. Slower execution. Performance can be significantly slower due to the overhead of real-time translation. And source code exposure requires the source code to be present on the target machine, which might be a security concern. And runtime errors. Errors might only be discovered when that specific line of code is executed, making some bugs harder to find. And probably this is the part where I really feel confident. Haspy source code ins knack-knacks without a tile binaries several popular constinct fum. GCC GNU compiler collection. A widely used open source compiler supporting C, C++, Objective-C, Fortran, Ada, and Go. Known for its strong optimization capabilities and broad platform support. Microsoft Visual. C++, Break, Microsoft's proprietary C++ compiler, integral to Visual Studio. Offers deep interaction with Windows development tools, robust debugging, and specific optimization for Windows platforms. Conclusion: empowering your C++ journey. Understanding the role of compilers is candidate to writing efficient and robust C applications. While interpreters offer flexibility, compilers excel in performance and creating deployable software.